Right now, at this exact moment, something is slicing through the outer edges of our solar system that shouldn't exist. We're tracking an object designated 3I/Atlas, and it's currently making its closest pass to Earth at roughly 270 million kilometers. That might sound distant, but in cosmic terms, it just brushed past us. And here's what's keeping astronomers awake tonight. This thing is doing something no natural object should be able to do. This is only the third confirmed interstellar visitor we've ever detected, following the infamous Oumuamua and Comet Borisov. But 3I/Atlas isn't just passing through, it's transforming in real time, defying every model we've built to understand how comets behave. The data streaming in from observatories worldwide is painting a picture that makes even hardened skeptics pause and whisper a question nobody wants to ask out loud. Let me show you what's happening right now, because the numbers don't lie, and what they're telling us is absolutely unprecedented. 48 hours ago, 3I/Atlas was barely visible, a faint smudge requiring professional equipment to detect. Standard physics predicted a simple story, gradual brightening as it approached the sun, then a predictable fade as it departed. Textbook stuff, except that's not what's unfolding above us. Instead, the object erupted, not a gentle brightening, but a violent spike in luminosity that sent astronomers scrambling to recalibrate their instruments. But forget the brightness for a moment. What's truly bizarre is the color shift, and I need you to understand how wrong this is. As 3I/Atlas crossed the frost line, it blazed an electric blue. Okay, we've seen that before. Carbon monoxide sublimating off the surface, ionized nitrogen catching solar radiation. Chemistry 101. Then, approaching its closest point to Earth, the spectrum twisted. Blue surrendered to a piercing, unnatural green. Still explainable, diatomic carbon, cyanogen gases reacting to ultraviolet bombardment. Unusual chemistry, but nature can be weird. But then, in just the last 6 hours, something happened that has no comfortable explanation. The green is vanishing, overtaken by a metallic golden shimmer that looks less like gas and more like polished metal catching sunlight. There are almost no natural processes that create sustained gold coloration in a cometary tail. Sodium can produce yellow-orange flares, but the spectral signature we're recording doesn't match. What we're seeing looks solid. It looks manufactured. And that's when the high-energy data arrived and everything got exponentially stranger. While optical telescopes watched the impossible color show, Hubble and the Chandra X-ray Observatory were examining 3I/Atlas in frequencies invisible to human eyes. Comets do emit X-rays through a process called charge exchange, when solar wind particles slam into the gas cloud surrounding the nucleus. We expected a soft, diffuse glow, the cosmic equivalent of a gentle haze. What we detected instead were sharp, rhythmic pulses, structured, regular. A NASA report updated just minutes ago used the word exotic to describe the emission pattern. When scientists deploy that word, it's code for "we have no idea what's causing this." The amplitude, the sheer intensity of the X-ray signal is far too powerful for the thin gas cloud we're observing. Thin gas equals weak X-rays. That's physics. But we're measuring thin gas and blindingly intense X-rays simultaneously. The equation doesn't balance. Which means the solar wind might not be hitting a diffuse cloud at all. It could be striking something solid, something with a conductive metallic surface that's generating these X-ray spikes as it rotates through the solar wind. If you spin a conductive metal sphere through charged particles, you get exactly this kind of signal. And that possibility is what's making some researchers very, very uncomfortable. So we're watching an object that shifted from blue to green to shimmering gold while pulsing with high-energy radiation in a structured pattern. Take a breath and think about what that actually means. Now layer in the thermal data, because this is where the anomalies start compounding into something that can't be dismissed. Comets are dirty snowballs. They heat up unevenly, crack, vent gas explosively from the sunward side. This causes chaotic tumbling, wild rotational changes as jets of gas fire off unpredictably. We call this non-gravitational acceleration, and it's messy, violent, random. 3I-ATLS should be tumbling like a drunken gymnast as it sublimates. But the light curve, the graph tracking how its brightness changes over time, is eerily smooth. It's not tumbling chaotically. It's rotating with mechanical precision, like a satellite maintaining attitude control. The rotation period is locked and stable. If this were crumbling ice, venting gases would be spinning it up or slowing it down unpredictably. Instead, 3I-ATLS maintains perfect rhythmic rotation, almost as if something is actively stabilizing it. That stability is what's allowing the golden flash to appear so consistently, pulsing like a beacon. On, off, on, off. Precision where there should be chaos. Let's talk about that gold surface because the implications are disturbing. An object traveling through interstellar space for millions of years gets sandblasted by cosmic rays, turning the surface dark and reddish. Oumuamua looked exactly like that, tumbling red rock. 3I-ATLS started dark too on approach. But as it warmed near the sun, that dark outer layer appears to have shed, revealing whatever's underneath. And what's underneath is reflecting sunlight like a mirror. The recent NASA analysis mentions evaporating gases like cyanogen, explaining the green phase. Fine, but gold requires a completely different explanation. Some mineralogists suggest iron-rich silicates or concentrated sulfur compounds, except sulfur doesn't reflect like polished metal. Here's the number that should make you pause. The albedo, the reflectivity of this object, has skyrocketed to nearly 80% in just hours. Fresh snow reflects about 80%. Enceladus, Saturn's ice moon, is one of the most reflective bodies in the solar system. 3I-ATLS is now rivaling Enceladus in reflectivity. But Enceladus is pure ice. 3I-ATLS is hot, basking in full solar intensity at 1.8 astronomical units. At that temperature, ice should be violently sublimating, creating a massive chaotic gas cloud. Instead, the coma surrounding 3I-ATLS is tight, controlled, almost aerodynamic, like it's being shaped by something other than random gas expansion. We haven't resolved the nucleus directly. It's too small, too distant even for Hubble to see more than a point of light. But we can infer shape from the light curve. Oumuamua was bizarrely elongated, cigar or pancake-shaped. 3I-ATLS appears different. The light curve suggests symmetry, hinting at geometry rather than the random potato shape typical of asteroids. The data is whispering something that makes careers dangerous to say out loud. This object might not be random. As 3I/Atlas drifts through Hydra's constellation, visible now with binoculars in the southern hemisphere, we're assembling a puzzle where the pieces don't fit the standard model. A comet that doesn't tumble, a gas cloud pulsing hard X-rays, a dirty snowball shining like polished gold with geometric symmetry and stable rotation. The cognitive dissonance in the scientific community is palpable. You can hear it in the carefully worded press releases, the hedged statements, the conservative language designed to avoid career-ending speculation. But underneath that caution, the data is screaming that this is unique. And that uniqueness has reignited a controversy simmering since 2017, because there is another hypothesis that fits all these anomalies with disturbing elegance. It's been championed by one of Harvard's leading astrophysicists, and tonight his predictions are looking less like friend speculation and more like prophecy. Because if nature is struggling to explain 3I/Atlas, there's another framework that accounts for everything we're seeing. And that framework requires us to consider a word that makes mainstream astronomy deeply uncomfortable: artificial. Dr. Avi Loeb, former chair of Harvard's astronomy department, has been arguing for years that we need to seriously consider the possibility that some interstellar objects aren't natural. He suggested Oumuamua might be a light sail, an argument that earned him ridicule and fascination in equal measure. Now, with 3i/Atlas, he's published a case that's as compelling as it is controversial, laying out 18 distinct anomalies suggesting this object was manufactured. Let's examine his most explosive claims, because some of them are genuinely spine-chilling. The trajectory is the first bombshell. When you trace 3i/Atlas's path backward through the decades it spent crossing the void between stars, the vector of its arrival aligns almost precisely with the region of sky where the famous WOW signal originated in 1977. The WOW signal remains the strongest candidate for an extraterrestrial transmission we've ever detected. A powerful, narrow-band radio burst lasting 72 seconds, never repeated, never explained. It's been analyzed for decades with no natural explanation that satisfies everyone. Loeb asks a question everyone's thinking but few dare vocalize. What if the WOW signal was a beacon, a handshake protocol? And what if 3i/Atlas is the physical response, arriving nearly 50 years later? The probability of a random interstellar object entering our solar system along that exact vector is, according to Loeb, calculations, approximately 1 in a billion. One coincidence, maybe, but we're just getting started. The second major anomaly is the anti-tail. Most comets have tails pushed away from the sun by solar radiation and wind. 3i/Atlas has that, but it also displays a sharp spike of material pointing directly toward the sun. In normal cometary physics, this is usually an optical illusion caused by viewing angle. Dust particles along our line of sight create the appearance of a sunward tail. But the geometry of 3i/Atlas doesn't support that explanation. The anti-tail is too defined, too persistent. Loeb proposes an alternative that sounds like science fiction but fits the data. It's not a tail. It's exhaust from a propulsion system firing against solar gravity to maintain a specific trajectory. Because here's the third anomaly, and this one is mathematically staggering. 3i/Atlas isn't just passing Earth. It's threading an impossibly precise path through our solar system to set up a rendezvous with Jupiter in March 2026. Think about what that requires. Enter the solar system from interstellar space, pass Earth at exactly 1.8 AU, then intercept Jupiter months later. The precision needed for that sequence is astronomical, literally. Jupiter isn't just a target, it's the gravity well of the solar system, a massive shield protecting the inner planets, but also a source of immense energy. A probe seeking to refuel or planning to use a gravity slingshot to accelerate toward its next destination would aim exactly where 3i/Atlas is going. Loeb argues the trajectory is too perfect, too optimized. It looks less like a random rock's path and more like a flight plan programmed by something intelligent. And then there are the signals, and this is where things get genuinely eerie. In the last 24 hours, amateur radio astronomers and independent observatories have flooded social media with reports of anomalous radio bursts coming from 3i/Atlas's direction. Short, sharp pulses. NASA has officially classified them as solar noise, interference from our very active sun. Fair enough, solar flares create radio interference all the time. But here's what's unsettling. The bursts are periodic. Solar noise is random, chaotic. These signals have rhythm, structure, a beat. Some independent analysts examining the data claim the modulation pattern resembles compressed data transmission. Imagine a probe silent for centuries, waking up as it approaches a star system, scanning the third planet for hours, collecting terabytes of atmospheric composition data, electromagnetic emissions, maybe even visual reconnaissance. Then, as it departs, it compresses everything into a high-density burst and transmits. That's exactly what these periodic radio signals would look like. We have visual anomalies, gold color, geometric symmetry, stable rotation. We have trajectory anomalies, WOW signal origin point, Jupiter intercept precision, and we have electromagnetic anomalies, structured X-ray pulses, periodic radio bursts. Any single anomaly could be dismissed as natural weirdness, but all of them together? That's what Loeb calls reaching the threshold where Occam's razor starts cutting the other direction. Is it simpler to invent 5 different unprecedented natural explanations for one object, or is it simpler to accept one explanation, artificial design, that accounts for all 5? The skepticism from mainstream astronomy is healthy and necessary. We can't leap to aliens every time something unusual appears, but the natural explanations are becoming increasingly convoluted, requiring belief in a unique type of comet made of unique materials, following a unique trajectory, emitting unique radiation, all by pure accident. It's a statistical nightmare that compounds with every new data point. And while the debate rages, the object isn't waiting for consensus. It's moving, and not just moving fast, it's moving wrong. Because while we've been arguing about colors and origins, the James Webb Space Telescope has been tracking 3I/Atlas's position with exquisite precision, and the position is wrong. The object has deviated from its predicted path. The celestial mechanics of our solar system are clockwork. We can predict a comet's trajectory to within meters using nothing but gravity calculations. Every planet's pull, every interaction, it's all perfectly predictable. 3I/Atlas has deviated by thousands of kilometers in a way that gravity alone cannot explain. This is the non-gravitational acceleration phenomenon we saw with Oumuamua, but more dramatic, more blatant. If you throw a rock, you know exactly where it lands. If the rock changes course mid-flight, something is acting on it. And that something isn't gravity. The deviation happened precisely as 3I/Atlas passed its closest approach to Earth. This is the moment of maximum gravitational interaction with our planet, yes, but our models already account for that. We factored in the Sun, Jupiter, Earth, even the Moon's influence. The math predicted position A. The telescope shows position B. The difference is delta V, change in velocity, and it's significant. If this were simple outgassing, the rocket effect of sublimating ice, we'd see correlation with solar heating. Gas jets push away from the sun. But the vector of this deviation has a lateral component. It moved sideways relative to the sun. Nature doesn't do sideways. Nature does away. A lateral shift implies deliberate maneuvering, a controlled vector change. Speculatively, if this were artificial, such a deviation could represent a braking maneuver or course correction, and the timing is what makes it chilling. Why correct course right here, right after passing Earth? Because this is the optimal moment. If you're a probe scanning a planet, you want stability during data collection. Then, once the scan is complete, you adjust trajectory to hit your next waypoint. The timing suggests the observation phase ended and the transit phase began. An ESA expert commented that the movement is consistent with low-thrust, high-duration propulsion. Low-thrust, high-duration. That's ion engine terminology. That's spacecraft language. But the trajectory shift isn't the only new activity. Observatories in Japan and Europe are recording something else: increased flickering in the ultraviolet spectrum. The Subaru telescope in Hawaii and the Very Large Telescope in Chile both report that 3I/Atlas is flickering rapidly in UV light. Comets flicker, yes. Dust clouds are turbulent. But this flickering is fast, happening at frequencies measured in hertz, not minutes or hours. And it's regular. It has pattern. It resembles modulated signal transmission. If you flash a light down a fiber optic cable to transmit data, that's modulation. Brightness and dimness encoding information. We're observing a UV source on this object brightening and dimming in patterns that look disturbingly like binary code. Could it be evaporation? Maybe a rotating vent creating a strobe effect? Possibly, but a rotating vent powered by sublimating ice would slow down as material depletes. This strobe is constant, undiminished, as if powered by something other than evaporating volatiles. The combination of trajectory deviation and UV modulation paints a picture of an active machine. It adjusted course, it's pulsing with structured energy, and it's doing this while heading away from us, deeper into the solar system. There's zero collision threat. The object is safely receding. But the psychological impact is immeasurable because we're watching something that appears to act with intent. When we plug the new trajectory into our models, simulating where that 60,000 kilometer deviation takes the object, we see something remarkable. It doesn't just move 3i Atlas away from Earth randomly, it fine-tunes the arrival time at Jupiter. The deviation ensures the Jupiter encounter happens at a precise moment, to the second. It's not escaping Jupiter, it's optimizing the intercept. The visit to Earth wasn't the mission, it was reconnaissance. Jupiter might be the destination, the main event, and what happens there in 2026 could make tonight's observations look like a preview before the feature presentation. We need to look ahead because the object is leaving Earth behind, but not leaving the story. The next chapter will be written in Jupiter's shadow, and the models predict 3i Atlas won't just pass by. It will interact with the giant in ways that could fling it clear out of the galaxy or potentially bring it back. Let's examine what March 2026 might reveal. The trajectory adjustment we just observed has placed 3i Atlas on a precision approach to Jupiter, and the geometry of this encounter is what we call a gravity assist. We use this technique constantly. Voyager, Cassini, New Horizons all stole momentum from Jupiter to accelerate toward their destinations. But 3i Atlas is approaching differently. Natural objects typically fall into chaotic orbits near Jupiter. The planet is a comet destroyer, capturing them, tearing them apart, or hurling them into the sun. 3i Atlas is aiming for something specific, a narrow corridor above Jupiter's cloud tops that maximizes velocity boost without capture in the lethal radiation belts. The probability of an interstellar object randomly entering our solar system, passing Earth at optimal scanning distance, then hitting the perfect gravity assist vector at Jupiter is vanishingly small. It's like throwing a dart from New York, bouncing it off a wall in Paris, and hitting a bullseye in London. If we follow the artificial hypothesis, the Jupiter flyby serves two purposes. First, propulsion. By diving deep into Jupiter's gravity well, the object gains massive speed, potentially enough to achieve galactic escape velocity. It's the perfect exit strategy from our solar system. The second purpose is more intriguing. Jupiter isn't alone. It's surrounded by moons with subsurface oceans, Europa, Ganymede, Callisto, worlds that are prime candidates for life. If 3i Atlas scanned Earth for surface biology, it would logically scan Europa for subsurface life. And here's the critical detail. The course correction near Earth, that 60,000 kilometer lateral shift, was exactly what's needed to align with the orbital plane of Jupiter's moons. Without that adjustment, 3i Atlas would pass at high inclination, missing the moons entirely. With the correction, it threads directly through the equatorial plane, getting front-row access to the ocean worlds. If you were designing a reconnaissance mission to this solar system, you'd visit Earth and Jupiter. They're the two critical data points. Earth for biology, Jupiter for the moons and energy resources. 3i Atlas is hitting both in sequence, with a course correction in between. The Jupiter encounter will also be a stress test. Jupiter has the strongest magnetic field in the planetary system. If 3i Atlas is electronic, if it has internal systems, if it generates its own magnetic field, Jupiter will light it up. The interaction between the object's field and Jupiter's magnetosphere could create auroras, radio bursts, and synchrotron radiation visible from Earth. We might finally see this thing fully activate in ways we haven't witnessed yet. There's also the question of return trajectory. Current models show hyperbolic orbit. One way in, one way out, never coming back. But those models assume the object is an inert rock. They assume no propulsion. If 3i/Atlas activates engines at periapsis, the closest approach to Jupiter, it could exploit the Oberth effect. A small thrust at that point yields massive changes in final velocity. It could use that energy to decelerate, to enter orbit, to stay in our system. Or, as Loeb speculates, it could use Jupiter's energy to power a transmission, sending compressed data back to its origin using the sun's gravitational lens to amplify the signal. If this is natural, the coincidences are 1 in a billion. But if it's a probe, Earth was the scan, and Jupiter is a communication relay. The encounter in March 2026 will be the final exam. If it behaves like a comet, we'll know. If it maneuvers again, if it adjusts orientation to scan Europa, if we detect engine burns, the debate ends. We'll have our answer. For now, the object is drifting from the warmth of the inner system toward the cold darkness beyond. It's fading from view, but not from attention. The data collected in these few days has already changed history, regardless of final conclusions. Let's examine the endgame. What happens after Jupiter? After the 2026 encounter, 3I/Atlas begins the long journey into the outer dark. By the 2030s, it crosses Neptune's orbit. By the 2040s, it's in the Kuiper belt, and then it's gone, returned to the interstellar void. NASA confirms the object won't return. Its velocity exceeds solar escape speed. It's not gravitationally bound. It's hyperbolic. Fall in, swing around, shoot out, never seen again. If it's a rock, this is goodbye forever. But 3I/Atlas has a history of defying predictions. Even if the object never physically returns, the implications of its visit are permanent. If Loeb's framework holds any truth, the departure isn't an ending, it's a beginning. Because if 3I/Atlas is a probe, it has a mission protocol, and missions have reporting phases. Speculatively, the object could activate high-gain antennas after Jupiter, transmitting collected data back toward its origin system. Atmospheric composition of Earth, radio signatures from our civilization, high-resolution imagery. If that data is received light years away, it could trigger a follow-up mission. Not 3I/Atlas returning, but others arriving. The scout has reported back. The next visitors might not be silent watchers. The WOW signal was a single burst. 3I/Atlas might be the reconnaissance. What comes next could be first contact, or simply another mystery, another watcher, silent and inscrutable. We're no longer looking at the sky the same way. Before Oumuamua and 3I/Atlas, we assumed everything in our solar system belonged here. Now, we know we occupy a busy intersection of interstellar trajectories. The Galileo project, founded by Loeb, is building dedicated observatories to detect the next visitor months or years in advance. We're constructing a planetary awareness system, not just for asteroids, but for whatever else might arrive. The legacy of 3I/Atlas is forcing the question into the open. It's made us look at flickering light and wonder if something is signaling back. It's forced consideration that the anomalies aren't errors, but features of technology we don't yet comprehend. Despite zero collision threat, the object safely receding toward outer boundaries, this event could revolutionize our understanding of the cosmos. If the speculations are confirmed, 3I/Atlas becomes the first evidence of extraterrestrial engineering, the Copernican revolution of our time. We're no longer the center of biological development. We're one data point among many. For now, 3I/Atlas remains mystery, drifting across the sky, visible with binoculars for a few more nights in the southern hemisphere, a tiny golden pinprick of light. Ghost, machine, or rock? Belief doesn't matter. What matters is that it was here. It touched our system. It potentially changed our trajectory. As it fades, it serves as a reminder that the universe is full of surprises, that we're small, and the dark is deep, and we've only just begun to open our eyes. If you could send the message back with 3I/Atlas, one sentence to whoever might have sent it, what would you say? Are we ready for contact, or should some doors remain closed? The answer might arrive sooner than we think, written not in radio waves, but in the trajectory of the next visitor, because now we're watching, and we'll be ready for whatever comes next. Keep looking up. The sky is no longer empty.